In this video, we're going to be investigating a special right triangle that has degree angle measurements, 30 degrees, 60 degrees, and then of course 90 degrees. So there's my right angle, 90 degrees. This other bigger angle here that's at the bottom is 60 degrees, and the smaller angle at the top is 30 degrees. Okay. We want this triangle to have hypotenuse 1. So the hypotenuse is the side opposite the right angle, and so there's our hypotenuse of 1. And we need to know what the other two side lengths are. So we'll talk about the short side length there at the bottom, and then the long side length here is the vertical measurement there that's on the side. And we need to know what these are. Now, this is a special right triangle, and perhaps the ratio that you could look between any two sides here would be something that you would have had memorized. However, I don't usually like to lean on memorization as much as using tools that I do have and use frequently to build different concepts. And so what I'm going to do here is notice that this 30, 60, 90 degree triangle, if I reflect it across over here and just copy that triangle on the side here as well, what I end up having then is just a copy here. This would be a 60 degree angle again at the base, 30 at the top. And I actually have the whole triangle made up of the two smaller triangles is a equilateral triangle, because see, that angle there at the top is the 30 degrees plus 30 degrees, which would be a total of 60 degrees, and the other two angles there are 60 degrees as well. So equiangular means equal lateral, this all sides being equal to. And so knowing that the hypotenuse of that first triangle was 1 tells us that the hypotenuse of the second triangle is 1, as well as the fact that this whole other side here is length 1 as well. Okay. Now, I did just reflect this triangle over, so the two triangles that I'm looking at are in fact congruent triangles, and so that whole base of the equilateral triangle is split into two equal parts, each one by that right angle that's being dropped down there. And so if the whole length is 1, each one of the parts is going to be length 1/2. And so that just leaves me to find one extra piece here, this vertical part right there, that I'm going to call A. Okay? And so looking again at my original right triangle, I have one of the side lengths is A, so I'm going to utilize the Pythagorean theorem, and I'm going to say leg length squared, so A squared, plus the other leg length squared, so 1/2 squared, is equal to the hypotenuse length squared. Okay, and so I'm going to go ahead and compute those values. I've got A squared plus 1/2 squared would be 1/2 times 1/2, which is 1/4, is equal to 1 squared, which is simply 1. And I want to solve this equation for A, and I notice that there's only one term that has A in it, and it happens to be A squared. So I'm going to isolate that A squared term first by subtracting 1/4 from each side. And so I have 1 minus 1/4 would be 3/4 there is equal to A squared. And to undo the squared, I would square root both sides, and when I do, I've got to remember that technically speaking, if I'm solving the equation, I need to have the plus or minus, but I know that I'm looking at a physical right triangle here with side lengths that are positive, and so I'm really only taking the positive root there. So my answer would be A is equal to the positive square root of the fraction 3/4. But that's not a super nice way to write A, so instead I'm going to use exponent rules, which are also these root rules. That would be the square root of the top over the square root of the bottom. And I happen to know what the square root of the bottom is, and so that would be the square root of 3 on top over the square root of 4, which is just 2 on the bottom there. And so we know then that that remaining leg has distance square root of 3 over 2. And so overall, just so that we don't lose track of this triangle that we started with, we've got a right triangle, 60 degrees at the bottom there, 30 degrees at the top, and I had hypotenuse 1. The shorter side length is opposite the smaller angle, and that happens to be 1/2, and the longer leg length is opposite the bigger remaining non-right angle, and that happens to be our A, which is our square root of 3 over 2. And so that's our other special right triangle that we're going to be utilizing to build the unit circle.